With this balloon demo, we talked about what our excess and limiting reactants actually were. And remember, we had that balloon that had the extra baking soda left at the bottom, but how much is actually there of our excess reactant? That's what we're going to calculate today. So let's look at a real-world example. If you're making grilled cheese sandwiches, you need 2 pieces of bread and 2 pieces of cheese for every 1 sandwich. So if I have 28 pieces of bread here, I can make 14 sandwiches. And if I have 43 pieces of cheese, I can make 21.5 sandwiches. So from our knowledge of limiting and excess reactants, we know that we're only going to be able to make 14 sandwiches total, because after we make 14, we'll run out of bread. However, the question we want to answer today is how much of my excess reactant, or how much of my cheese, will I have left over? So, to make our 14 sandwiches, we use 2 pieces of cheese apiece, which means we only need 28 pieces of cheese. So this equation here tells us how much cheese I'll use up. However, the question asks, how much will I have left over? So, I take my available amount of cheese, my 43 pieces of cheese, or my available reactant, and I subtract out the 28 pieces of cheese, which is the amount I will actually use. And I have 15 pieces of cheese left over. So as you saw with our grilled cheese sandwich example, what you're going to do is figure out the amount available, which is given in the problem, and you're going to subtract out how much of your reactant you're actually going to end up using. And then you can figure out how much you're going to have remaining. So if you have 28 slices of bread available and you only use 7, you should still have 21 left, because we can just subtract. Let's apply this to chemicals. See if you can do A through D in the next problem, and then we'll look at E together. Alright, so with our chemicals, we're told that we have lithium and oxygen. Mix them together, we get lithium oxide. So you guys can write this balanced reaction. And then we're told we have 3 moles of lithium that go in and 2 moles of oxygen. So we converted to figure out how much lithium oxide we would produce, which was 1.50 moles. Remember, we use the smaller numbers. So 1.50 is smaller than 4 because the 1.50 is when all of our lithium will run out and we won't have any more. So then lithium is our limiting reactant and our excess reactant is oxygen. So what we're trying to answer today is, after this reaction, how much oxygen would actually be left. So what we do is we take our 1.50, and this is how much lithium oxide will actually be made from the reaction. So if I look at my ratio right up here, for every 1 mole of oxygen gas that goes in, 2 moles of lithium oxide are produced. Easy enough. So then that means that in order to make 1.50 moles of lithium, we need 0.75 moles of oxygen. Okay, following me so far? Now, if we have 2 moles available and we only use 0.75, we can subtract. If we have 2 moles available and we're only going to use 0.75 moles, then we have 1.25 moles that would be left over, correct? I want you to try this problem on your own. Okay, let's see how we did. We took our calcium chloride and our manganese 3 oxide and we mixed them together and we got manganese 3 chloride and calcium oxide. Easy enough. You guys can write a balanced equation by now. And then we used our stoichiometry and we ended up with 6 moles of manganese chloride if we started with manganese oxide, and 3.33 if we started with our calcium chloride. So calcium chloride is our limiting reactant and our manganese 3 oxide is our excess reactant. So what we need to determine now is how much of that excess will be left. So again, we take how much we'll make, 3.33 moles of our manganese 3 chloride. So we're starting with our 3.33 moles of the manganese 3 chloride. Then we can figure out we need 1.67 moles of the manganese 3 oxide to make that happen. So we have 3.00 moles available, and we subtract out how many we've actually used. 1.67 moles Mn2O3, and we end up with having 1.33 moles of our manganese oxide left over in the end. Alright, hopefully from this video you're able to understand how to determine how much of your excess reactant is left over. If not, you can either read section 9.8 in your book, or you can come in and see me before or after school. Remember to take the assessment along with this video. The password is CHEESE, C-H-E-E-S-E, and I will see you in class next week.